All right, you guys. So today we're going to be dealing with the same thing, okay? Constant and proportionality. You guys know that my R is y over x, okay? Again, we have two rules we have to follow. We have to start at 0, 0, and all my ratios have to be the same, right? All my fractions need to be the same, okay? So here we are. We're going to just jump straight to it, okay? Now, we're going to be talking about tables here. And whenever you guys are dealing with your tables, just like the alphabet, X will go first, Y will go second. Now, in the formula, the equation up top, it is Y over X. You are correct. But for the tables, it's always X, and then it's Y, okay? So first things first, 0, 0. Do we start at 0, 0? Yes, we do. So that's good. I don't want to use it, but it's still something that we need to check. Okay? Now, I'm going to go through and I'm going to do the fractions for you guys, but please understand the most common mistake that I'd seen is that kids are forgetting which one is y. We're putting it backwards for some reason. So we do y is y over x. And if we look at our fraction under the y value, that 3 over 5 is my y value, so 3 over 5. And then my x value is this 1 over 5, so I'm going to put 1 over 5. All right, well, remember, you guys, whenever we're dealing with fractions and we're dividing, let's keep, change, flip. So keep this fraction, change this sign, flip that sign. And then we just multiply straight across. 3 times 5 is 15. 5 times 1 is 5. All right, cool. Well, hey, let's factor these things down. We know 15 is not prime, but that's 3 times 5. And I know those are both prime. And then 5, yeah, 5's prime, cool. So I'm just going to put a 5 down here. And then remember, your goal at this point is just to cross things off. So I'm going to cross off those. I'm left with the 3. And on the bottom, there's just a 1. So we got to go and make sure that every other fraction is 3 over 1. And if you watch the other videos, we should have caught up by now. But if you do those other two, I'm telling you right now, we're just going to kind of skip that part. All the other fractions also come out as 3 over 1. Okay? So I know my R, my proportional relationship, is 3 over 1. That is our R. But hey, right here, I've got y equals Rx. That's the equation that we're going to start doing. Okay? So once we find what R is, once we see that all of my relationships are proportional, I just plug it into the R. Okay, so again, y equals Rx. But we just said that R was 3 over 1. So there we go. Boom, we're done. Again, it starts at the origin. Yes, we know that. And if you were to do all the relationships, all the fractions, they would all be 3 over 1. I'm only doing the fraction part of it just so you guys can see that, okay? But if you tested out all the other ones, they're all the same. And then we just plug in that factor in for R, or the ratio, the relationship that we have there. Okay, now, because this says determine, we are unsure if it is a proportional relationship or not. So whenever you see the word determine, the main thing that you guys got to understand is that we got to try all the fractions, okay? Now down here, I'm going to change something up on you. I know it says determine, and that means we got to try all the fractions. But to be honest with you, I want to put something different here. I want to say that this is proportional. So we're already stating, hey, this is proportional. So if it is proportional, I don't need to try all of them. I just need to try one, okay? So we know it's proportional because I just changed the question to say that now. So first things first, see we have 0 paired with 0? That's good. Now from here, we just got to pick a pair of numbers. We could do the fractions. We could do 18 over 30. We could do 9 over 15. I think the easiest one to do is 9 over 15, okay? And remember, x first, y second. All right, well, my y are these ones down here. So I got 15, and then the paired number with it is 9. Well, let's factor these things out. Okay. I got a 3, I got a 5, a 3, and a 3. Make sure you put them with the right one. So 15 was 5 times 3, or 3 times 5. And then 9 is 3 times 3. All right, well, hey, 3's cancel out. And I'm left with 5 over 3. Cool. So you guys know what your r is now. Let's go to the equation. Y equals Rx. But hey, I know what R is. R is 5 over 3. Okay? So your goal, let's see if it's proportional. If it is proportional, okay, then we go through and put that R into the fraction, or the equation, sorry. Now something like this next one, hey, let's see if there's a proportional relationship. I don't know yet, we gotta try. So I got my X, I got my Y. The first one, I got a 3 over 2. But hey, both of those are prime. So 3 over 2, cool, that's just as far as I can get. But right here, hey, I got a mixed fraction, and I know that little rule is, let's multiply 4 times 1. 4 times 1 is 4, plus the one up top, so right here. You multiply these two, 4 times 1, that gives us 4. 4 plus 1 is 5. The denominator is still the 4. Okay? Now, with this said, okay, we want to test these two numbers, but remember, the y comes first, okay? And I'm going to test this one, y over x. But remember, we do the y first, so I got 5/8 divided by, and then that last one is 5 over 4. And then, hey, with this right here, just like we did on the first one, we want to keep, change, flip. So 5 over 8 times 4 over 5. We multiply it straight across. So 5 times 4 is 20. 8 times 5 is 40. Let's break these things down. So 20, 5 times 4. Hey, I know this right here. And then we break down 2 times 2 is 4. Cool, those are my prime numbers for 20. So 2, 2, 5. And then my 40 is 10 and 4. But hey, neither of those are prime, so I got to break it down more. So 2 and 5, and 4 is 2 times 2, yeah? So we put all these numbers down. I got a 2, a 2, a 2, and a 5. Then we start crossing stuff off. Hey, all that's left on the bottom is a 2. What do I fill the top with? Are these answers the same? No, they're not. So, hey, this is not proportional. I don't need to write anything. Okay? So your goal, if it says they're proportional, you just need to test one and write an equation. If we don't know, then we need to test all of them and see if they are the same. And if they are, then we place that number into the equation. So there we go. Now we're dealing with graphs, okay? Now, first thing you got to look at, do we start at 0, 0? No, we don't. So, hey, boom, I don't need to do anything. This is not proportional. Although it's a straight line, and we said, hey, if it starts at 0, 0 and it's a straight line, it's proportional. This one doesn't start at 0, 0, so this one's not proportional. I don't need to write an equation for that. Okay? But then my last one, hey, do we start at 0, 0 here? Yeah, we do. So now we just got to find our letter R. We find an intersection here. Cool. Remember, this is X, this is Y. So if I go down to my Y value, my X value, I got a 4. I got a 4 for my X value. And then for my Y value, I got a 9. So we use that. All right, well, let's break these numbers down. That's 3 and 3. That's 2 and 2. Let's see if we can cancel anything out here. Hey, nothing cancels out though, so 3 times 3 is 9. 2 times 2 is 4. That's my R. And again, it says determine if this is a proportional relationship, but we talked about it before. If it starts at 0, 0, which it does, that's one of my rules. But my other rule is it must be a straight line. Is this a straight line? Yeah, it is, huh? So then from here, we take that 9 over 4 and we just plug it into our equation. You guys know, hey, as long as I start at 0, 0, and as long as it's a straight line, I can create any equation that I want, okay? See you guys.